Hello, welcome to another episode of Math with Mikel. On this episode, we are going to look at modular arithmetic. Under it, we are going to treat the modulus of a number, the modulo of a negative number. We will also look at addition and multiplication table in a given modulo, and also solve some illustrative examples. We will look at some miscellaneous examples as well. Before we get into it, kindly subscribe to the YouTube channel Math with Mikel, and put on the notification bell so that anytime we drop a video, you'll be notified. Modular arithmetic. Now, if we talk about mod, what do we mean? Now, the notion or the idea of modular arithmetic is related to the concept of the remainder in division. So what that means is, anytime you hear about mod or modular arithmetic, what should come to mind is remainder. Now, any number in a given modulo is found by dividing the number by the modulo, and the remainder is the value we are interested in. In general, if you are working in mod n, where n is any whole number, we write a is equal to b mod n if a leaves a remainder of b when you divide it by n. Let's take an example. 13 mod 2. To solve this, you ask yourself, 2 divides what will give you 13 or an answer close to 13. So we know that is 6. So we say that 6 times the 2 plus what should be 13. So if you perform that simple calculation, you realize that if you multiply 6 by 2, we get 12. 12 plus 1 will give us 13. So we say that 13 is equal to 1 in mod 2. Let's take another example. 20 mod 5. So you ask yourself, 5 divides what gives 20 or an answer closer to 20. We all know that is 4. So 5 times 4 plus a certain remainder we don't know is 20. So 20 plus the r is equal to 20. Then we know r, which is the remainder, is 0. That's the case. We can conclude that therefore 20 is equal to 0 in mod 5. Okay, so try the following examples yourselves. 121 mod 12. So you can take your time, pause the video and solve it yourself before checking the answers. 25 mod 4. So the answer for the first one is 121 is equal to 1 in mod 12, and the answer for the second one is 25 is equal to 1 in mod 4. So let's take note. If the number is less than the mod, we leave it as it is. Let's take a look at an example. 2 mod 5. Now the number 2 is less than the mod, which is 5. So the answer becomes 2 is equal to 2 in mod 5. We have 8 mod 13, and the answer becomes 8 is equal to 8 in mod 13. 14 mod 20, the answer becomes 14 is equal to 14 in mod 20. So from the example, you realize that all the numbers are less than the mod. Let's look at our next subtopic, modulo of a negative number. Now, the modulo of a negative number is obtained by adding multiples of the modulo to the number until we get the first positive number. So you keep adding the mod to the negative number until we obtain our first positive number. Example, we have -9 mod 4. So the solution. So -9, we add the mod, which is 4, to it, and we get -5. Now -5 is not a positive number, so we keep adding the mod. So we get -5 plus 4, and that gives us -1. -1 is still not a positive number, so we keep adding. So we get -1 plus the 4, and that gives us 3, which is the first positive number. So therefore, we say that -9 is equal to 3 in mod 4. Example 2. We have -2 mod 5. So the solution. we add the mode, we get negative 2 plus 5, and that's 3. So therefore, negative 2 is equal to 3 in mode 5. Try the following questions. We have negative 5 mode 2. So you can pause the video and work out the solution yourself before checking the answer. So we conclude that negative 2 mode, so negative 5 mode 2 is equal to 1. Please subscribe to the YouTube channel. Also like this video, and don't forget to share this video to reach your colleagues. The next subtopic: addition and multiplication table in a given modulo. The sum or product of two or more numbers in a given modulo is formed by first adding or multiplying the numbers before converting your answer to the given modulo. Let's take an illustrative example. So we have negative 10 plus 4 in mode 5. So we will first work out the negative 10 plus 4. That gives us negative 6. And negative 6 in mode 5, we say it's 4. The next one, we have 4 plus 5 in mode 5. So we work out the 4 plus 5, which gives us 9. And 9 in mode 5 is 4. The third one, you have 4 times 8 in mode 5. And that gives us 32 in mode 5. We get 2. And the last one is 8 times 12 in mode 13. And the final answer is 5. 8 times 12 gives us 96. Note: subtraction is also performed in the same way as addition and the multiplication. Also, the values are obtained by first adding or multiplying the numbers before converting them to the given modulo. Sometimes you wouldn't be given the set of values to use to draw the table. In that case, let's say if you are being given to draw in mode 5, you use the set of numbers from 0 to 4. If you are asked to draw addition table in, let's say, mode 6, if the set of numbers are not given, you use 0, 1, 2, 3, 4, and 5. If you are asked to draw in mode 7, and if the numbers are not given, we use 0, 1, 2, 3, 4, 5, 6 in that order. Sometimes you'll be asked to draw the addition or the multiplication table for a given set. In that case, you will use the set you've been provided to draw the table. So with this one, let's say if a question is given, the set or a particular set will be given, and that will be what you use to draw the table. So I have an example here. The table below shows the arithmetic table for mode 8 on the set. So in this case, a particular set has been given. So you use that set to draw your table. So let's take an illustrative example. Draw an addition table for arithmetic mode 5 and use the table to evaluate we have 2 plus 4 or plus 3 plus 4. 2 plus 3 or plus 4. And we have 2 plus into bracket 3 plus 4. We are asked to use the table to find the true set. The true set of 3 plus n is equal to 2. So the solution, we draw our table nicely. Now since we are working in mode 5 and the set of values were not given, we are going to use 0, 1, 2, 3, 4 for our row and the column. So that's what we have there. Now the next to do it one after the other. So 0 plus 0 is 0. 0 plus 1 is 1 in mode 5. I've already told you that if the number is less than the mode, we leave it as it is. So 0 plus 3 is 3. 3 mode 5 is still 3 since 3 is less than the 5. Let's take a random one. The 2 plus 3 will give us 5. Now 5 in mode 5 is 0. 2 plus 4 is 6. 6 in mode 5 is 1. So we use the idea to fill in all the values to complete the table. So the B, we are asked to use the table to evaluate. We have 2 plus 2 plus the 3 plus 4. So from the table, you can see that 2 plus 2 is 1. And the 3 plus 4 from the table is 2. So we get 1 plus 2. And from the table, 1 plus 2 is 3. That answers the I. The same idea for the II. We do the 1 in the bracket first. So the 2 plus 3 gives us 0. And we get 0 plus 4. We still give us 4. And everything is in mode 5. The third one, we have 2 plus into bracket 3 plus 4. Now the 3 plus 4 will give us 2 from the table. And we get 2 plus 2. And that gives us 4. So the last part, which is the B, we are asked to find from the table the truth set of 3 plus n is equal to 2. So basically they are asking us to find 3 plus what will give us 2 from the table. So from the table, we realize that 3 plus 4 will give us 2. So the truth set becomes n is such that n is equal to 4. And that answers the B part of the question. Thanks for watching this video. Please subscribe to the YouTube channel, Math